A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Hello students, assalamu alaikum. Again, this is Usama Yub, and today's our second lecture of your second week. Okay, today's lecture is second lecture, week number 2, and now we will continue the lecture from previous lecture. Okay, so in the last lecture we have discussed in detail. In the last lecture we have discussed in detail about Coulomb's law, and after the discussion about in detail about Coulomb's law, we have also discussed the vector form of Coulomb's law, because we have discussed that Coulomb's force is a force which acts between two charged particles. These charged particles can be like or unlike, and if the Coulomb's force is a force, so force is a vector quantity, and if a force is a vector quantity, so Coulomb's law has also a direction and has a vector. Okay, so we have also discussed the vector form of Coulomb's force or Coulomb's law. Okay, so these two topics we have already discussed in detail about in the last lecture. If you have any queries and any questions about these topics, so you can ask the question in live session. Okay, so in the last class, we have already discussed about this numerical. I only discussed the question about this numerical, and I said to you that we have discussed in detail this numerical in the next class. So in this class, in the beginning of this class, we have discussed this numerical. The numerical, what is the numerical? Figure 6 shows 3 charged particles. This is the figure 3. Okay, this is the figure 3. So figure 6 shows 3 charged particles held in place by force not shown. What electrostatic force owing to the other 2 charges act on Q1? Means these are 3 charged particles, Q1, Q2 and Q3. Q1 is at the origin, where Q2 is placed on purely x-axis, and Q3 is placed on in between positive y-axis and negative x. Okay, in between positive and negative means Q3 is placed in the second quadrant. Okay, so these 3 charged particles are placed. This is a configuration of these 3 charged particles, and the magnitude has also given. Q1 is equal to minus 1.2 microcoulomb, Q2 is equal to plus 3.7 microcoulomb, and Q3 is equal to minus 2.3 microcoulomb. Because Q1 is a negative charge, Q2 is positive charge, and Q3 is negative charge. And what is R12 and R13? R12 is the distance from charge 1 to charge 2, means this is R12. From Q1 to Q2 is the R12. R12 is given 15 centimeter, where R13 is the distance between charge 1 to charge 3, means Q1 to Q3. So R13 is 10 centimeter, where theta is equal to 32 degree, means if we consider R1 and if we consider Q1 and Q3, so there is a force which will be exerted, and Q1 and Q3 both are negative sign, because so both are the same sign. And we have already discussed in the last class that if we have two same sign, so both charges repel each other, and if these both charges repel each other, so the direction of F13 will be in this direction in fourth quadrant. If the Q3 is placed in second quadrant, so the direction of F13 will be in fourth quadrant, and the theta will be created here in with respect to the fourth quadrant. Okay, the theta will be created here, and the value of theta is 32 degree. Okay, now so this is the data which will be created from this figure. Now, so how can we solve this numerical, and how can we find the electrostatic force between these two charges? F12 is equal to K Q1 Q2 over R square. Okay, means force between charge 1 to charge 2. If we choose force Q1, force between Q1 to Q2, so we use F12. F12 will be equal to K Q1 Q2 over R square. K, the value of K we have already known, that 8.99, or we can use 9 exponent 9. We can all both values are approximately same. Okay, so 8.99 into 10 to the power 9 Newton into meter square per coulomb square. 1.2 microcoulomb is Q1, and 3.7 microcoulomb is Q2. I want to clear one thing here, that 1.2 Q1 is our negative charge, and if we see in the problem, the question, if we see in the question, Q1 is equal to minus 1.2 microcoulomb. So why we not use minus in solution? Because I want to clear one thing, that Q1 we take a magnitude of Q1 and Q2. Okay, we take a magnitude of Q1 and Q2, and if we take a magnitude, so the magnitude, if we use magnitude, so there is no need to show the sign. Okay, because if you use a magnitude, so the minus will become positive. Okay, so F12, after calculation, F12 will become 1.77 Newton. Okay, now next step, what is the next step? Next step is we will find the force F13, the magnitude of force. We have only solve the magnitude first. Okay, first we will only solve the magnitude. Okay, so F13 will be equal to K Q1, not Q2. We will use K Q1 and Q3. Okay, we use K, this is Q1 and this is Q3, this is not Q2, because we are use Q1 and Q3, and if we use Q1 and Q3, so you use Q1 and Q3, not Q2. We cannot use Q2 because we have we want to know the force, Coulomb's force from charge 1 to charge 3, Q1 to Q3. So we use K, this is the value of Q1 and this is the value of Q2, and we have already discussed that we we have used the magnitude of charges, so we cannot use the negative sign. Okay, and this is the R square. We have used R13, we have already known 10 centimeter, and if we convert centimeter into meter, so the 10 centimeter will be equal to 0.1 meter. Okay, so 0.10 meter square, because square is in the formula. So we have got F13 will be equal to 2.48 Newton. So now we have already F12 and we have already F13 known. Okay, after the solution of F12 and F13, now we will we can find the force exerted on charge Q1. Okay, because we only know the force, the resultant force of q1. Okay, because if q1 is placed on the origin, so the q3 is also exerted the force on q1, and q2 is also exerted on q1. So q1 face two forces, q1 are facing two forces, q2 and q3. If q1 forces two forces, so what will be the resultant force? So now we will find the resultant force, and if we want to find resultant force, so we must resolve x component or y component, because the q3 is placed in between x or y axis. Okay, so f1x, we use the term 1x because f1 stands for charge 1. So the force exerted on x axis will be f1x will be f12x plus f13x will be equal to f12, which we have already find, f12 and plus f13 sine theta. Why we use only f12? Because if we see the force vector f12 is purely on x axis, there is no any component towards y axis, so the y component of f12 will be 0. So we use only f12 purely of f12. Okay, now look here, the theta is created with x axis. If the theta is created with x axis, so we will use f13 sine theta with f of x. We have resolved two component, f of x and f of y. If theta is created with y axis, if theta is created with y axis, so fx will be equal to f sine theta and fy will be equal to f cos theta. Okay, another we want to clear again that theta is created with y axis. Theta is created with y axis, not x axis. Okay, clear this thing. So f1x will be equal to f12 plus f13 sine theta. We have already known f12. We also know f13. What is the value of f13? So we put here and calculate. After the calculation, we got 3.08 Newton. And now solve y component. If you want to solve y component, f1y will be equal to f12y plus f13y, and f12y will be equal to 0. Why f12y will be equal to 0? Because if we discuss the force vector of f12 is purely on x axis and f12 is purely on x axis, so the y component of f12 will be 0. Okay, the y component will be 0. We have only the f13 component, f13 cos theta. Okay, so the f13 cos theta, we have put the values and we got 2.10. So f1x will be equal to 3.8 and f1y will be equal to minus 2.10. So what will be the resultant? What will be the resultant? This is my question, that what will be the resultant? We have f of x and f of y. What will be the resultant? We all know that how can we find the resultant value if we have x and y value. F of x square plus f of y square under root. Okay, f of x square plus f of y square plus under root. F of x square, okay, plus f of y square under root. Okay, so this is the formula of resultant f. Okay, so we can find the resultant value. The resultant value will be 3.73. okay, now further move on the next. This is another sample problem. So sample problem number 4, the average distance r between the electron and proton in the hydrogen atom is 5.3 exponent minus 11 meter. What is the magnitude of the average electrostatic force that acts between these two particles? And the part B is, what is the magnitude of the average gravitational force that acts between these particles? Means you have to find two different forces, Coulomb's force as well as the gravitational force. We have already discussed in the last lecture that gravitational force are same as Coulomb's force, or you can say that Coulomb's force is same as the gravitational force. Only difference is that gravitational force use two masses, where the Coulomb's force use two charges. So both forces are like forces. Okay, the formula of both forces are as same with each other. So find the electrostatic or Coulomb's force. So here formula K Q1 Q2 over R square. So K, we have K 8.99 or 9 into 10 to the power 9, 1.6 into 10 to the power minus 19 square over 5.3 exponent minus 11 meter square. Okay, because we have electrons and proton. We have discussed about the average distance between electron and the proton in hydrogen atom. Okay, so the charge of electron is also 1.6 and the charge of proton is also 1.6. So we use 1.6 exponent minus 19 whole square. Okay, as where in gravitational force we use mass of electron separately and mass of proton separately, because mass of proton and mass of electron both are different, but the charges are same, the magnitude of the charges are same. Okay, so here the Coulomb's force will be 8.2 into 10 to the power minus 8, where the gravitational force will be 3.6 into 10 to the power minus 47 Newton after the overall calculation. If you have any question, any problem, so you can ask in a live session. Okay, now further move on the next slide, and in the next slide, now in this we have another problem. This is another problem, and what is the problem? Read this problem. The nucleus of an iron atom has a radius of about 4 exponent minus 15 meter and contains 26 protons. What repulsive electrostatic force acts between two protons in such a nucleus if they are separated by a distance of 1 radius? So we all know the gravitational force, the Coulomb's force will be equal to K Q1 Q2 over R square. K, we discussed about two protons, the distance between two protons, the attraction between two protons. So there are two protons, charges of protons we also used in the previous sample problem. So the 1.6 into 10 to the power minus 19 whole square, and the distance has already given 4 into 10 to the power minus 15. So after calculation we got 14 Newton. Okay, now these are the some problems related to Coulomb's force or Coulomb's law, which will be important for your course point of view, and which is most important from your paper point of view. So I want to discuss that problems. After the Coulomb's force, there is another an important topic which we will discuss in detail, that the electric field. This is another main topic of electrostatic. Okay, so what is the electric field? The electric charge creates an electric field in the space around it. A second charged particle does not interact directly with the first, rather it responds to whatever field it encounters. In this sense, the field acts as an intermediary between the particles. The electric field strength is defined as the force per unit charge placed at that point, and this is the formula of electric field. What is the formula of electric field? The force per unit charge. The force per unit charge is electric field. Actually, electric field is created in space around any charge particle. Okay, means if you have positive charge, if you have negative charge, positive charge creates its own electric field, and negative charge creates its own electric field. And read this statement. This is another important statement. A second charge particle does not interact directly with the first. It means that a first charge particle creates an electric field around itself, around in and create electric field in space around it, but that second charge does not interact directly with the first. Okay, the second charge will interact with the help of the field. Okay, now move on the next slide. So the electric field strength at any point could be represented by an arrow drawn to scale. However, when several charges are present, the use of arrows of varying length and orientations becomes confusing. Instead, we represent the electric field by continuous field lines or line of forces. Means what do you mean? Means that if you have a positive charge, the positive charge creates electric field outward from a charge. Okay, and the negative charge with the negative charge, the electric field direction will be inward. The electric field direction will be inward, and the in negative charge, and the electric field direction will be outward in the positive charge. Okay, so this is a charge alone placed in the space. If we have a one charge, okay, if we have two charges of unlike sign, means if we have a positive charge and another charge is negative, so if we have two charges, so the lines will be, the electric field will be created in this configuration. Means the electric field will be created from positive sign, and the direction of electric field will be outward from positive sign and will be inward in the negative sign. Okay, and so as this, the electric field will be out from positive sign and will be inward in negative sign. Okay, and if we have two positive sign, if we have two positive or two negative signs, means if we have two same sign, so what will happen if we have two same sign? So we have already discussed that the positive sign creates an outward electric field, so the configuration will be like this. Okay, so this is the electric field. And what is the formula for electric field? We have already discussed. Electric field is electric field is the force per unit charge. Means F will be equal to force per unit charge, force over charge, F over Q. E will be equal to F over Q. So another thing is that if we place a point charge in electric field, means we have an external electric field which will created between two charge particles or two charge plates, positive or negative. So if we place a charge particle in between positive and negative plate, so what will happen? So let a positive test charge Q naught be placed a distance r from a point charge Q. The magnitude of force acting on is given by Coulomb's law. Because we have already discussed that Coulomb's law is the electrostatic force, in which we have discussed the charges which are in stationary condition. Here also point charge is also in stationary condition. So Coulomb's force will be equal to K Q1 Q0 or Q0 or Q1 Q2 over R square. So this is the Coulomb's force. And if we place this force in the formula of electric field, the formula of electric field is E is equal to F over Q0. So if we place the formula of F, if we place this value into this, so what will happen? 1 over 4 pi epsilon naught Q over R square. It means that if we place a point charge in electric field, so the electric field will be like this, K Q over R square. This is the electric field according to Coulomb's law. Okay, this is the electric field according to Coulomb's law. Now further move on the next slide. So here we have a formula, we have a sample problem related to electric field. First of all, read the sample problem. A proton is placed in a uniform electric field E. What must be the magnitude and direction of this field if the electrostatic force acting on the proton is just to balance its weight? Okay, so we want to find electric field, and we have discussed about proton is placed in uniform electric field. So what will you do? We will do replacing Q naught by charge of electron, because we have already know here proton is in use. Okay, so the charge of proton will be 1.6 exponent minus the charge of proton is 1.6 exponent minus 19. Okay, so electric field will be equal to F over Q naught. Here force will be equal to mg and charge will be equal to E. So charge is 1.6 exponent minus 19 coulomb, where mass of proton is 1.6 exponent minus 27 kg, and the gravity we all know the gravity 9.8 meter per second square. Okay, so the electric field, after the calculation we have got the electric field 1 exponent minus 7 Newton per coulomb. Okay, so this is the sample problem. Now we move further. This is another an important sample problem from your course point of view as well as from your exams point of view. Okay, so first of all read this sample problem, because this sample problem is a very logical sample problem. Read this sample problem, figure 3. Where is figure 3? This is figure 3. Figure 3 is here. So figure 3 shows a charge Q1 of 1.5 microcoulomb and a charge Q2 of 2.3 microcoulomb. The first charge is at the origin of an x-axis and the second charge is at a position x is equals to L, where L is equal to 13 centimeter. At what point P along the x-axis is the electric field 0? Means now move on the figure 3. This is the figure 3. We have two charges, q1 and q2, where q1 is placed on purely on the origin of where q2 is placed purely on the x-axis from the origin of q1. Okay, q1 is on origin and q2 on purely on x-axis in the direction of q1, in the direction of positive x-axis. Okay, so all you know that positive signs create outward electric field. So q1 is also creates its own electric field, and q2 is also creates its own electric field. The direction of q2 the direction of electric field of q2 is towards q1, and the direction of electric field of q1 is towards q2. Got it? Okay, so if both charges repel with each other due to the opposite direction, so there must be a point where the electric field will be 0, because both charges repel each other, and both charges the direction of electric field will be opposite with each other. So must be a point where electric field will be 0. So consider P is a point where electric field will be 0, and L, capital L is the length between q1 to q2. Okay, and X is a distance between q1 to the point where the electric field will be 0. This is the X. Okay, so we all know the both charges are here. q1 is 1.5 and q2 is 2.3. so the position where electric field will be 0 is this. Means that if we discuss about a position, so this is a point where electric field 1 and electric field 2 will be 0. Means this is a point where both electric fields will be 0. So E1 will be equal to kq over r square, and E2 is kq2 over r square. In the last slide we have already discussed the Coulomb electric field according to Coulomb's force. So we have used the formula kq over r square. We have also kq over r square. But if we discussed about electric field of one charge, so we have used kq1 over x square, because if we see on this figure, so at the location of this point, what is the formula of E1 according to charge q1? kq1 over x square. And if we discuss about E2, kq2 over L minus x square, because we have know that from q1 to P there is a distance of x. So what will be the distance from P to q2? What will be the distance from P to q2? So this is the L minus x. This is the L minus x. So we have used L minus x whole square. Okay, so rearranging all of these, because we want to find x, because x is a position where electric field will be 0. X is a position, or x is a distance where electric field will be 0. So x is equal to, after the calculation we have used first of all 1 over 4 pi epsilon naught will be cancelled, because both are same on the left hand side or the right hand side. So k or 1 over 4 pi epsilon naught will be cancelled. And if we want to solve x, so x will be equal to L over 1 plus under root q2 over q1. And if we place the values which already given in the data or in the numerical, so in the final we have got result 5.8 centimeter. Okay, so this is the numerical related to the electric field. If you have any problem to understand this numerical or understand the overall lecture, so you can ask question and you can ask freely. Okay, so these are the some electric fields, some standard electric field which have test in laboratory. So now uh, we will stop here because we have we got a lot of time. Now in the next slide we will discuss we will discuss from here in the next lecture. Okay, we will discuss from next lecture from here because we have not too much time. Okay, thank you. We will meet in the next lecture.